Ladies and gentlemen, good evening. Tonight I'm going to talk about RabbitMQ and how to set up Deadletter queue, Deadletter handling in general. And I read this really cool piece of documentation from RabbitMQ, which is called dlx.html. It's right there, rabbitmq.com/dlx.com, and dlx stands for Deadletter Exchanges. And here you can actually see what kind of properties can be set. We can set a deadletter exchange that we want to go to when we end up in a deadletter situation. But let us go back to the drawing board first, and let me show you a bit of theory of what is actually going on and what is a deadletter queue, what does it do, and what is a deadletter exchange, and why is it there. First of all, when we are dealing with when we are routing messages through to a queue, it's always true, or almost always true, an exchange. You can also create some. You can actually also route or send messages directly to a queue, but that is not what is thought behind RabbitMQ. You need to send a message to an exchange like this. So this is let me name this my exchange 1. So this is just an exchange that I create. And then usually, of course, there are different ways of routing these messages that come here. One of them is by topic, and if you use a topic type, then you have a routing key. So this is the topic type. That means that then you have a routing key attached to your messages, and then depending on what the routing key says, then you will end up in different queues. Maybe you have a queue, my queue1 over here. That is then bound to the exchange with a routing queue. So that means that there is a binding. I just created a binding right here. So that means that there's a binding to my queue1 if the routing key equals something, maybe Q1 or something like that, right? Or matches a pattern. Usually it's pattern you can use, and then you can use the hashtag as a wildcard for one or more words, and the asterisk is exactly one word. So usually you would have a pattern like this. And then all the messages that end up in on this exchange, and it has this routing key Q1, and then they will end up in my Q1. There can actually be multiple, of course there can be multiple matches, so maybe we'll have more than one queue where the routing key actually matches. Then we will just end up having the message being placed in multiple queues. So that means that then we will have copies of the message placed in multiple queues, and that is of course also fine. So here we have my Q2. Right there, and then we'll just have another binding, as it's called on the exchange, my Q2, and then maybe the routing key here should match Q2 and then something, and then we will then we will route to Q1 or to Q2. What will happen sometimes is that that maybe we don't have any consumers for my Q2. There's no consumers right now that will take exactly this kind of message, or maybe the message cannot be handled by the consumer. Let's say we have a consumer out here, consumer that listens on the queue and actually extracts the messages whenever they show up. So we have a consumer there. But when we get this, some of the messages from my Q1, they cannot be treated by the consumer, so they are just being placed back, maybe with a not acknowledged, and then return to queue option enabled, and then that means that the queues will just continue being circled around here, around and around for eternity. That's where the deadletter queue actually comes in. There could also be that some of the messages inside the queues are actually never picked up. Maybe we don't have a consumer for my queue. For my Q2 right here, so this is message 1 right here. It will never be picked up. Then we have something called time to live, which can actually place these messages or route these messages to another exchange when the time to live setting has been exceeded. When the timeout has been exceeded, the timeout is per default in milliseconds. So that means that each queue can actually have this TTL setting, TTL equals something. Maybe it's in tonight I'm going to set it to 30 seconds. That means 30,000, and then we can see that after the message has been there for 30 seconds and not being picked up by a consumer, then what will actually happen is that the message will be routed back to another exchange. So I'll create a new exchange here, and this is named a Deadletter exchange, or in short DLX. So this could be my DLX1 right here. So this could be my DLX exchange one right here. So that means that on the queue itself, I would have an option that actually sets which Deadletter exchange should be sent the message to when they exceed the time to live. And then in this situation, it will be my DLX1 like this. And we will also have a routing key, a DLX routing key, a Deadletter exchange routing key, or the Deadletter routing key, DL routing key, ARCO equals something, 1, 2, 3, 4, or whatever we want it to be. And then after the 30 seconds, then if we have message 1 right here, then it will be sent to this exchange right here. And then on the exchange, of course, then we will have a binding to another queue. So we can have a bounding to, maybe this could be DLQ for Deadletter Q1 or something like that. And then, of course, some messages will actually end up in this Deadletter Q1. And of course, we need to look at these messages once in a while to see what actually went wrong. Why do we have messages in the Deadletter queue in the first place? We were not supposed to, this was usually not supposed to happen. You can have some scenarios where it's okay that it happens. Maybe it's just have a busy consumer or something like that. And to DLQ1. Maybe with the routing key named something like 1, 2, 3, 4, and then .pound. That means that then the messages will be routed to this queue right here. But we need to look at this. Most times we need to look at the Deadletter queue and then see what should be changed in our setup. Should we change something in the consumers? Should we change something? Maybe with the timeout should just be increased a little bit. There's another situation where a message can be routed from a queue to the Deadletter exchange. That is, if the consumer text says, okay, let me read the message, and then it says, then it does not acknowledge the message, it does not give a knowledge, and it does not give the return to queue. It does not call the return to queue. That's still set to false when it's getting the message. That would actually then also end up in a routing to a Deadletter exchange. So if you acknowledge a message, of course, that's fine. Then the consumer said, okay, this is my message, just delete it from the queue, that's fine. But if you do not acknowledge that you have the message, and if you do not say return to queue, then you will end up, it could end up in a Deadletter exchange like this, and then be routed to a Deadletter queue like this. I hope this makes sense, because now I'm going to show you how to do this through the UI, how to set up a queue to actually have a Deadletter exchange, and how to have I will also set up the Deadletter exchange to point to a Deadletter queue, and then we can actually see how it works. I'll set a timeout for 30 seconds, maybe even less, just because I'm impatient. I will not show you any code today, but I am planning to create another video where I'm going to do this with Java code instead. So let us just get started. First of all, I've created a project right here, and this project is a Spring Boot project, and I only prepared this for later use, but also so I had a place to set my Docker Compose file where I have my RabbitMQ management image. So and then I'm exposing those ports right there. And the 15672, that is important port tonight, because that is the management port. Default username and password are guests and guest. But the project, I created a project by choosing Spring Initializer 11, Java 11, that's what I'm using right now. And then I gave it a good artifact name. I chose Gradle, just because I prefer that. Use Maven if you like that. Next, I ticked off Lombok. I ticked off RabbitMQ, and that is just because it's a very easy way for me to get the RabbitMQ and the AMQ dependencies that I'm going to use later on in a later video. Then I ticked off Spring Web, and then I pressed next, finish, and then I ended up with this project right here. Then I created the script folder right there, and then I created the Docker Compose file, which is right here. And that's actually it. Then I went to the directory where we have the Docker Compose file, and then I wrote Docker Compose space up, and that is what's running here. It's not running as a daemon, it's running as a just in the terminal right here, that I can follow what's going on in the terminal output. You can also see here I actually typed in wrong credentials right here, admin invalid credentials right there. So that was before I remembered that it was actually just guest. So let us get started. First of all, this is I went to localhost 15672, then I typed in guest, and then I ended up right here. And the first thing we want to set up is an exchange. So I went to exchange, and I'm going to create a new exchange, my exchange 1 right here. I'm going to route to my queue by using the topic. That means that I need a good routing key for each queue when I'm going to bind it. I want durable messages or message exchange, and that is because if something stops, then when I start it up again, I still want my messages at the current exchange. I also want the exchanges itself. I don't want them to just be deleted. So let me add my exchange 1. So now I have an exchange. The other thing I want a Deadletter exchange 1, which I'm just shortening with DLX1. And again, I want to use the topic. You want to use a routing key. Add again. So now I have these 2 exchanges right here. Exchanges are no good without a queue. So let us go create a queue. Classic queue. Yes. This could just be my queue 1. I'm going to keep it simple. So I'm just going to have 1 queue right now. So this is 1 queue, yes. And look down here. Here you have some really interesting. You do not need to look up all the settings. You can actually just press right here that you want a Deadletter exchange. The first thing we're going to set is Deadletter exchange, and I'm going to set this to DLX1. And then I want a Deadletter routing key. That means the routing key, and I can write something with the DLX. Timeout or whatever. Yeah, I can decide myself what I want here. It could also just be test 1 or something like that. So now I have a lot of words separated with a dot. I just need to remember that when I'm matching the routing key on the binding that we are going to create in just a while. Message TTL, time to live, that is TTL. That means that I want this message to live for 20 seconds, let us say 20 seconds. And remember to tick off number right here. Need to be a number. And that is actually it. Another way actually a message can end up on the Deadletter queue is if we exceed the max length bytes. So that means that if you have set a maximum number of bytes on it and this is exceeded, then the message will also be routed to a Deadletter queue. So it is a cool way of actually watching what is going on in my routing system, what's going on with all my messages, and remember to look up and pick up the messages from your Deadletter queue once in a while, because it is probably because there's something that could be tweaked a little bit better in your system, or maybe something that needs to be handled differently. My Q1, let me have a DLQ1. Right here, this is my Deadletter Q1. And on this one, I could also set up a time to live. I could also set up a Deadletter exchange and a routing key. So that means that I could actually continue routing to another place, to another exchange, if that's what I wanted to. But I do not want. I want to keep it simple tonight, so I'm just going to keep the Deadletter messages in the Deadletter queue right there. I'm not going to add another complexity to this one. So we have my Q1, we have DLQ1. Let me go back to my exchanges. Then I go to my exchange 1 right here. Binding, here's the binding. And then I write my Q1. And which routing key should we choose right here? We could choose test dot and then something. And then I just need to start the routing key with test dot, and then this binding should actually be chosen. So now I'm selecting this right here. Before I continue, I could publish some messages already now, but before I want to do that, then I want to set up a binding for my DLX to the DLQ1. So let me just do that. DLX1 right there. DLQ1 right there. Routing key. And now I need what was it that I said? What was it I said there? DLQ something. DLQ something. If it starts with DLQ, then we will send it to DLQ1. So that's a good binding there. So let me just check that the mic, which settings we actually had. They're right here. Deadletter routing key DLX. Okay, DLX. So I need to set it to start with DLX. Let me just change my binding. So DLX right there. My Q1 DLX dot something, and that's fine. And then let us delete this one right here. My Q1. Sorry, that was actually, yeah, I made a mistake there. It should just be, let me just write this again. My Q1, and then test is fine here. It was the wrong exchange that I'm fiddling around in right now. I'm sorry for that. My Q1, so this is my exchange one. I want to go to DLX instead, DLX1 right here, and instead of DLQ, it should have been DLX as the routing. So 2Q DLQ1. Routing key DLX dot something, and then the hashtag is just it's a wildcard. Let me just unbind. Okay, it's actually good. It's actually okay. We have two bindings, so it doesn't matter if I write DLQ or DLX in as the routing key in the Deadletter routing key as we have right here. Both of them will be placed into the Deadletter Q1. Okay, so now let me go to my exchange, and I'll send some messages to my exchange one right here, publish a message, and I'll just write test.test1. Then I'll write something, blah, 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 something here. Doesn't matter what we write right here. I'm going to copy this because we probably need it if we want to send some more messages. Publish message. Message published, that's really good. And it was also routed, or else I would have had an error message right there. Let me just see what happens now. Right now, my Q1 is right here. And also press the Q. Look here, we have one message. After 20 seconds, we should then see this curve go down to 0, because then we reach the timeout. So let me just check right here. Still have our message. I hope it will time out in soon. Yeah, look there. Now it's timed out. We have 0 messages in this queue right here. I am very proud. Let me just look what actually happened. So let me go to queues. Now it's in my Deadletter Q1 instead. I am so happy, because that means that we actually routed this to the Deadletter queue through the Deadletter exchange first, of course, and then it ended up in the Deadletter Q1 right here. Let me go get my message. Here we can see here NACK, N-A-C-K, that means not acknowledge, requeue true. If you do that, there's no problem. If you say not acknowledged but requeue false, if you do that, then the message could end up in a Deadletter queue at some point. And also reject it. I'm going to not acknowledge the message and requeue it, just because I want to see what's inside it. Here we can see this is the nice message that I just made before. And there's a lot of cool things that when it has been routed to a Deadletter exchange, then it gets all these properties here in the headers. So it gets an array with the key xdef. So it has this array right here of other properties, of other key value sets. It has a count. That's been the number of times it has been the Deadletter routed. And then it has an exchange. This is the exchange that it was on the last time. Then it has the queue, reason, expired, routing keys. That was routing key, time. What was the timestamp? And here we have the first exchange that was actually the first Deadletter exchange it was routed to, the first Deadletter queue it appeared in, and the first Deadletter reason. So that means that you can put up a pretty complex scenario if you want to, and then you will still know why it ended up in the first Deadletter queue at some point. I think I'm really proud of myself, but let us create one more message. It's a lot of fun, right? So first we go to my exchange one. I'm going to publish another message, and I'm going to copy the routing key. Tests, it can be test2 instead. I can say something. Hi, this is just a second message. And then I'm sending this publish. And let's go look. Queue, now it's in, we don't have, it's not received yet. It's not received. There came one message right there. One message. Let me just press right here again. We can see the timeout, 20 seconds. Then it should disappear. We still have it. We still have it. I know it's not that exciting because we just saw it actually. So now it goes down to 0, and that means that now the Deadletter exchange 1, it actually routed a message. And it routed it to the Deadletter queue, which we have right here. So now we have 2 messages in the Deadletter queue. Deadletter queue, so now we have 2 messages, and let me just go and look at the message. That was the first message, the test 1, that we requeued. Let me get the other message. Here we have the other message. Oh, that's still first message. Oh, here comes, it's still, okay, let us just steal the messages. Acknowledge and requeue false. So let's try that. Get the message. Here it is, blah, 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 something. And try again. This time we got, hi, this is second message. And yeah, that's the message. So now we have taken all of the messages. That means that now there will actually be 0 messages in the queue. You can see right here, we consumed the messages from the queue, as it's called. That's all for me tonight. Thank you very much for watching. And as I said, I will create another video where we do this Java-wise, exactly the same thing, just with Java code instead. It's very, very easy with RabbitMQ. It's such a cool tool. Yes. Have a great evening, and I hope to see you again soon. Bye-bye.